Today we're going to talk about some solutions, and the first thing we want to start with is some vocabulary. So I have it there on the yellow sticky notes. These are words that you've probably heard before in chemistry, but it's a good review from your honors chemistry. So we're going to start with solute versus solvent. Solute is the thing that gets dissolved. So if we were making salt water, the salt would be the solute. It dissolves into the water. The solvent does the dissolving, so in this case it would be the water, and usually this is the more abundant one. Abundant means that you have more of it. A lot of times it's a solid dissolved into a liquid, but it's not always. It can be a gas dissolved into a liquid. That's what your soda is when you have carbonated beverages. It can be solids dissolved in solids. It can be basically any state of matter dissolved in another state of matter. But most of the time in chemistry, we're going to dissolve solids into liquids. The next two words are saturated versus unsaturated. So these are measurements, and it's the most solute that you can dissolve into a liquid at a specific temperature. So there are several factors that matter when we're looking at how much stuff we can dissolve. One of them is how much solvent we have. So if you have a gallon of water versus a drop of water, obviously you can dissolve more stuff into a gallon of water. So the amount of solvent matters. It also matters how much the temperature is. So for solids and liquids, the higher the temperature, the more stuff you can dissolve. So if you like your tea really sweet, if you have hot tea, you can actually dissolve more sugar into the hot tea than you can into the cold tea. And once you've reached the saturation point, once it has dissolved as much as it can, if you added more sugar to it, it would just sink down to the bottom of the cup and it wouldn't actually dissolve into the tea. There is something called supersaturated, but that's kind of a special case, and we'll talk about that later on in AP Chemistry. I'll show you a video of a guy who's able to make a supersaturated solution. It's pretty cool. Though you have to do specific conditions to make it happen. But for this class, we'll consider the maximum solute dissolved is called saturated. And the last thing on those sticky notes is how things dissolve. So we have this phrase in chemistry that we say called like dissolves like, and that refers to polarity. So just as a reminder, polarity is when the molecule is not sharing the electrons evenly, when there's an uneven distribution of charge. So one side of the molecule is slightly positive and one side is slightly negative. So for like dissolves like, what that means is that if you have a polar solute and a polar solvent, they will dissolve into each other. If you have a nonpolar solute and a nonpolar solvent, they will dissolve. But if they're opposites, for example, vinegar is polar and oil is nonpolar. That's why oil and vinegar dressing settles out. So if you have like that salad dressing, or if you've seen it at a restaurant or something, you can see the two different layers, and to get them to mix together, you have to shake them up. But as soon as you set them on the table, they're going to settle back out. And that's because the oil is nonpolar and the vinegar is polar. So they do not dissolve into each other. And then there's also ionic. Most ionic compounds will dissolve in water, but there's you would use the solubility rules for those because there are some exceptions. All right, so let's look down here at this solubility graph. So this is kind of a crazy looking graph. You're going to have a ton of lines just going all over the place. And what this is showing is how much stuff you can dissolve into, in this case, water. So if you look at the x-axis, notice that temperature is on the x-axis. And just like I said a minute ago, the hotter the solids and liquids, the more you can dissolve, which is why the solid lines are having a positive slope. They're increasing. Notice that the solid lines are labeled as salts. Just as a side note, salt in chemistry does not mean table salt. So in the real world, when you say pass the salt, you're talking about sodium chloride. In the world of chemistry, salt means any ionic compound. So metal to a nonmetal, it can be magnesium chloride or calcium bromide, or any time you have a metal and a nonmetal together, or two polyatomic ions, it's going to be called a salt. So these are the most salts are solid, so they're going to increase as you increase the temperature. I'm not sure I mentioned it a minute ago, but gases actually decrease their solubility with temperature. So the hotter the temperature, the less a gas will dissolve into a liquid. So an example in your real life would be like soda. If you think about a hot day and you have a hot can of soda, the Coke doesn't taste as bubbly, and that's true because the soda can't hold as much liquid, or can't hold as much gas, the carbon dioxide, when it's hot. So gases are the opposite. They actually decrease, and notice that the dotted lines are decreasing. They have a negative slope on the graph. The last thing I want to talk about before we do some examples is the y-axis label. It's a long label. It says grams of solute dissolved into 100 grams of water. So remember, it matters how much stuff you have. So if you have a lot of water, you can dissolve more stuff. So you have to set that constant if you're going to graph it, or else you have too many variables. So for this one, our two variables are temperature and how many grams you can dissolve. And so in order to not have a third variable, they set that constant as 100 grams of water. So the y-axis would be your grams. It goes from 0 up to like 200 or however many grams. And then the x-axis is the temperature. So what you can do if you want to look at, say, this point right here on A, whatever temperature this is, if you measure it up and follow it over to the y-axis, this line right here, this grams, would be how many grams of A you could dissolve into 100 grams of water at this temperature. So a common question with this graph is they give you a point, like let's just say they give you a temperature and the amount of grams, and let's say the point is right here. And then they say at this point with this many grams and this much temperature, is D saturated, unsaturated, or supersaturated? And since this point right here, this one that I'm doing right here, since this is less or lower than the D line, then it means that it's unsaturated. This point over here with A, this point is saturated. So the points on the line are saturated. If the point is under the line, then it's unsaturated. And there's some examples in your progress check with a graph like this, the actual graph, not my drawing of a graph. And so you can actually check and see if you understand what this graph is showing. All right, we have just a few more things, and that involves the calculations. So the first calculation we're going to do is molarity. And the first thing is you need to start getting into your head that molarity is a measure of concentration. So they might not say in the question, what is the molarity? They might say, what is the concentration? So go ahead and start getting into your head that molarity is a measure of concentration. It tells you how many particles you have compared to the liquid. So for example, something that is a high molarity would be if you made Kool-Aid and you dumped a ton of red powder into just a little bit of water, you're going to have a very dark red sweet solution that's very concentrated. If you have a whole lot of water, a big bucket of water, and you just sprinkle a little bit of Kool-Aid in there, it's going to barely be faint pink, barely be able to taste it. That's a low concentration. So it's a ratio of how much stuff you have compared to the amount of liquid that you put it into. So molarity equals the moles of solute. And remember, the solute is the stuff that's getting dissolved. So how much, in this case, it would be the Kool-Aid. So how much Kool-Aid you put in there compared to the liters of solution. So the unit that people use for this, when you have a number, you can say you have 3 molarity, and make sure you do a capital M, or 3 molar, or you can also do 3 moles per liter. Either one of these two are acceptable for the units. And one more thing is that a lot of times molarity is going to be shown with brackets. So if they said the molarity of something, they can put brackets around it, and that means concentration as well. So molarity, concentration, and brackets are all the same thing, and it's just a ratio of moles to liters. So they could give you any of these 3 variables. They could give you the molarity and the liters and ask you how many moles is it, or they could give you the moles and the liters, ask you the molarity. So you just have to be able to solve for one of these variables. And if you have trouble, you can always put molarity over 1, and then you can cross multiply. However, be careful and realize that moles is interchangeable with grams. So if they give you grams to start with, you can't plug grams into this into this calculation. You have to first set up a fence, use the periodic table to turn grams into moles, and then you can plug it into this equation. Or if, let's say they gave you molarity and liters and they asked you how many grams is it, first thing you would do is plug both of those into the equation. You can go ahead and get the moles, and then you can set up a fence and turn moles into grams. Same thing with liters. This one has to be in liters. So if they give you milliliters, you need to convert it to liters first before you plug it into this equation. And again, there's 1,000 milliliters in 1 liter. And that is pretty much it for this equation. You're going to see a lot of times in the AP Chemistry word problems, you'll see where it says it's some kind of molarity, you have a certain volume of something molarity. So first of all, just as a side note, when you see the word of in a math word problem, it means multiply. So that's one clue. But another thing is you're just going to have to get used to when you have a volume and a molarity, when you multiply them, you get the moles. And like I said, I've been saying in several lessons now, if you don't already have moles, that's usually the first step, is to try to turn your stuff into moles, because you can do a whole lot with that. So just be aware of that as you start to do these AP chemistry problems, and recognize when you see molarity and volume, you're probably going to multiply them to get moles and then do something with those moles. All right, our second equation has to do with dilutions. When you do a dilution, we're going to go into detail with this, and you'll have to be able to explain how you actually do it. But for now, let's just review the equation that we used in honors chemistry. And that is that if you have an initial molarity and a volume, you can change the volume of one to get a new condition. Basically, it's kind of like P1V1 equals P2V2. It's where you have initial conditions and then you have final conditions. So remember, when you dilute something, you're changing the volume of the solvent, but you're not actually changing the number of particles that you have dissolved. So if you have that super sweet Kool-Aid and you add a whole lot more water to it, it's going to turn dilute. You're going to dilute it. It's a relative term. There's no definition of when something is dilute. It's just compared to other things. And so you can add more water to it, and that will dilute it. But you haven't changed the number of Kool-Aid particles that you put into it. So the reason this equation works, I always like to know the background of things, is that molarity times volume will give you moles. You see up at the top, if you multiply the liters times the molarity, you're left with moles. And so if the molarity times the volume gives you moles on the left, molarity times volume gives you moles on the right, they're equal to each other because the number of moles are not actually changing. And that's why this equation works. And we're going to do a whole lot with this as well. And you'll have to actually, if we were in class, you would actually do dilutions and explain how it works. But we'll definitely do a lot more with this in AP chemistry later. And that's it for this chapter. So make sure you do the progress check for this. And you only have one more review lesson after this.